Welcome back to Mr. Hassan's Maths channel. I'm now answering questions from the January 2023 International A-Level Edexcel Pure Mathematics P2 exam. So I'm going to go through this whole paper. I'm going to go through the questions one by one, saving the questions according to the playlist for the year, and this year, January 2023, and also by topic, so that I end up with playlists which are topic-wise and also year-wise. I'm going to go through this paper in such a way that I won't just be like a talking mark scheme, as I always mention. I'm going to go through it and try to explain in detail how to answer the questions for those students who either didn't pay attention or didn't, have proper teaching during their course. And so now at the end, they can maybe benefit from that. I'm also going to go through some of the common mistakes that I find that students make and, warn you about how to avoid them. All right, so let's start with question number one. Question number one here is about this curve, which is given the name y equals f of x. The table below shows some corresponding values of x and y for this curve. So we don't have an equation for the curve, but what we have is some x and y values. So when x is -1, y is 2.287, and so on. We have all of these values for x and y, and this curve is drawn. The values of y are given to 3 decimal places. We want to find or use the trapezium rule with all the values of y in the table to obtain an estimate for this integral between -1 and 1 of f of x with respect to x, and we need to give the answers to 2 decimal places. All right, so now basically we need to find the area under this curve. That's what this is. When we integrate between limits a curve, we're finding the area under the curve, and we're not actually able to find the integral because we do not know the equation of the curve. So we're going to use, as they told us to do, the trapezium rule. Okay, so even if we did have the equation and we could use integration, we would still have to use the trapezium rule because that's what the question instructs us to do. All right, so it's testing us on how to use the trapezium rule. Now this is where many students make some really silly mistakes. All right. Now one of the most common mistakes that people make when they use the trapezium rule, they just think about the formula. So they have the formula, it's in the formula book, and the formula is as follows. Okay, the area is equal to h over 2 times, and then you have like y0 plus 2 times y1 plus y2 plus y3 until you get y to the power of n minus 1, and the last one is yn. Something like this. So the first thing they make a mistake with is finding what h is. They know that h basically is, they have a formula b minus a over n. Okay, and that's what they make the mistake with. All right, they find the value of h incorrectly. Now, if you understand what the trapezium rule actually is, you wouldn't make that mistake. Okay, so a lot of people say n is like 1, 2, 3, 4, 5, n is 5, and they say 1 minus 1 divided by 5, and they make a mistake there. That's wrong. Okay, what you're doing when you're using the trapezium rule is as follows. You are basically making trapeziums from this area here, and the parallel sides go up at each of these points. So there's one going up at -0.5, which is like halfway between these two, and there's another one going up between 0 and 0.5, which is halfway between these two. Okay, so you've got these lines, and what you're doing is you are basically you are kind of estimating these to be, approximating these as little trapeziums. That's what you're doing. Okay, and you're finding the area of each of these trapeziums. That's what you're doing when you use the trapezium rule. You don't have to do all of this drawing what I'm doing here, but I'm just trying to make you understand what the trapezium rule actually is. Okay, so you can understand the formula better. So basically, we know that a trapezium, and these trapeziums will all be of this type of shape where you have something like this. The parallel sides will always be vertical. This is your h, this is your a, and this is your b. And the area of a trapezium is the distance between the parallel sides, which is h, divided by 2 times the sum of the parallel sides. So the first thing is you realize that h is basically the length from here to there, between -1 and -0.5 and 0 and 0.5 and 1. So we can see very clearly that the value of h is 0.5. Okay, it's not like you take these numbers and you say, oh, there's 5 numbers, so we do, 1 minus -1 divided by 5. No, that's wrong. It's actually the number of trapeziums which determines what n is. N is not the number of these values, it's the number of trapeziums. And when the table is already drawn and given to you, you don't even have to go through any of this. This is completely unnecessary to even look at this. When you have the table in front of you, you don't need to go through this, because you can see very clearly that the gap between each of these x values, that is your h. So that is 0.5, as you can see very clearly. You only really need to use this when they don't tell you a table of values, and you have to make the table of values yourself, and they say, divide this area up into 4 trapeziums. Then that's when you say, oh, n equals 4, let's work out what h is, subtract the x values and divide by the number of strips we need, and it will give you what the value of h is. Here we don't even need to go this way. We don't even need to do this at all. That's the first place where many students make mistakes. I've seen that many times, where they just say, 5 numbers, that's 5, n is 5, so 1 minus -1 divided by 5, that gives you 2 over 5, which is 0.4, but no, it's actually 0.5. Okay, that's the gap between these, because we don't look at the numbers, we look at the gaps between them, and we don't even have to do that here because it's table is already given to us. So we can see straight away that our h is definitely equal to 0.5. So the area of the trapezium is going to be given by 0.5 divided by 2 times. Now, the other thing is to understand this 2.87, that's the length of this line here. When x is -1, that's y. Y is up here. When x is -0.5, that's the length of this line here, okay, which is 4.407. So these are the lengths of the parallel sides. So if you think about it, you have the first trapezium, the second trapezium, the third trapezium, and the fourth trapezium. In the first trapezium, you're using this length, and you're using this length. So that length is being used in the first trapezium, and this length is being used in the second trapezium. In the first trapezium, sorry, both of them are using the first trapezium to find the area. So you're going to have this plus this, okay? And for the second trapezium, you're going to use this length again and that length. So you're going to use this length again for the second trapezium, and for, you're going to again use it in the third trapezium. So this length is used in the first and the second trapezium. This length is used in the second and the third trapezium. This length in the third and the fourth trapezium. But this length is only going to be used in the fourth trapezium. So these two are only used once. Okay, so what I'm going to do here is I'm going to say, okay, I'm going to say take these two numbers and I'll write them down once. 2.287 plus 2.834 plus, and then these are all used twice. Okay, so each of these are used twice. You have 2 times each of these. So you have 4.470 plus 6.719 plus 7.291. Close that bracket there, and the big bracket. That will give you an estimate of the area of this under this curve, of the sum of all these trapeziums. Okay, and the reason why we're adding them together is because you say the area is h over 2 times, let's call this y1 and y2. So y1 plus y2. Okay, and then you have the other one, h over 2, and this is y2 plus y3. Okay, so this is y1 and this is y2, this is y3, this is y4, this is y5. Okay, plus h over 2 times y3 plus y4. Okay, that's going to be this third trapezium. And the last trapezium will be h over 2 times y3 plus y4. So you can see h over 2 is common. And you have, y1 plus y2 plus y2 plus y3 plus y3 plus y4 plus y4 plus y5, sorry. Plus y4 plus y5. So you can see that the 1 and the 5, they're only used once, but the others are used twice. You have 2 of these and 2 of these and 2 of these. So you have y1 plus y5, first and the last, and 2 times y2 plus y3 plus y4. That's basically what we're doing here. We don't have to go through all that. That's where the formula comes from. I just want to show you that's what the formula is, so you understand better how it actually works. We don't have to go through any of this. I'm just giving that as a side point. All right. So once you've got used to using the trapezium rule, very easy. If the table is already given, h is the distance between the x values, which is 0.5, and it should be the same length, it's equally spaced. So that's 0.5 divided by 2. And then you take the first number and the last number and you write them down one time, adding them together. And whatever's between those, the ones in the middle, you add them together, but multiply all of them by 2. And that will give you your answer. So now all we need to do is to stick this inside the calculator. So you have 0.5 over 2 times, we have 2.287. Now you've got to be very careful. I'll use the table up here in case I've made a copying error. Very careful. The first and the last plus 2.834 plus, and then I'm going to multiply by 2 the rest of them. So 2 brackets, 4.4770 plus 6.719 plus 7.291. Close that bracket and close the big bracket and press equals, and we get 10.52025. So here we have to round it, as I said, to 2 decimal places. So it's 10.52 square units. So there's the answer to part A. I took a bit longer than you should do. I wanted to go through these, concepts, all right, because I see that that's a very common mistake. So the tables given, don't even bother doing this. Just look at the gap between the x values. That tells you the space between each of the parallel sides. That's the important thing. That's where many students make mistakes, and something that you should really be careful of. All right, so there's the answer to part A. So we end up with A equals 10.52 square units. So we're going to take that value. So we know that the integral between 1 and minus 1 of f of x with respect to x is 10.52. So I'll write that down because I think we're going to use that. Between minus 1 and 1 of f of x, the integral is 10.52 units. We don't need to write more decimal places because the original values are only given to 3 decimal places anyway. So it doesn't make sense to write the other numbers out. So that's fine. That's good, a degree of accuracy. It says use your answer to part A to estimate the integral of this. Now, what is this? F of x minus 2 dx. So this is where you have f of x and then you have minus 2. It's outside of the function. So to find this area, you could think about transformations, but that will be a bit difficult here because the whole thing's moving downwards. So what you can do here is you can do something that we know. We know that when we integrate two separate functions, for example, f of x plus g of x with respect to x, just like when we do, for example, x squared plus 3x plus 4 with respect to x. I'll write it like that, in fact. Okay, when we're integrating something like, for example, when we're integrating x squared plus 3x plus 2 with respect to x. Okay, what we actually can do, and what we actually are doing when we integrate without writing this step down, is we are integrating x squared with respect to x, and then we're integrating 3x with respect to x, and then we're integrating, I'll put a minus here just to make it clear, and then we're taking away from that the integral of 2 with respect to x. And this gives us x cubed over 3 plus 3x squared over 2 plus 2x plus c. We don't normally write this step down. We don't do this. But that's what we're doing. We're actually integrating each of these terms separately. Okay, that's what we're actually doing when we're integrating. All right, same with differentiating. We're differentiating each term separately. We don't think about that. We don't think about it in that way, but that way of thinking is going to help us to answer this question. Because what we can do here, we have two separate terms which we can integrate them separately. So we can say that this is equal to the integral between minus 1 and 1 of f of x minus with respect to x minus the integral of 2 with respect to x, again between minus 1 and 1. And that will give you the same answer as this, just as that gives you the same answer as this. All right, so that's exactly what we can do here. And we already have, this is the answer to part A, 10.52. So we can say this is 10.52. That's how we're using the answer to part A. And this is something we know how to integrate. 2 becomes 2x. We have our limits between -1 and 1. And so we have 10.52 minus, and we have 2 times 1 minus 2 times -1. Okay, so we end up with here 10.52 minus, you're going to have 2 minus minus 2, so 2 plus 2, which is 4. So you end up with 6.52 square units. Okay, so there's the answer to part B. Okay, B part 1. All right, so that's something that we should understand. It's based upon this principle here. It's very important for us to understand that. And then for part 2, it says integrate f of x minus 2 between 1 and 3. So the limits have changed. But what we can understand here is this is a transformation of this whole graph horizontally 2 spaces to the right. Okay, so I just prepared something a bit earlier to help illustrate this. So I'm going to take this. Did it put it anywhere? No, it didn't want to put it anywhere. Hold on. Okay, so what I've done is I've made a trace of this graph above it. And I want to show you that basically f of x minus 2, this is to do with transformations of graph. Okay, this is when you have the graph f of x and it's a transformation of 2 units to the right. Okay, that's a translation of 2 units to the right. That's what that represents. When you have minus 2 inside the function, the whole function moves, all the x coordinates change by adding 2 to each of them, and the y coordinates remain the same. So basically, this point minus, this whole graph is going to shift, according to this transformation, to the right by 2 spaces. Okay, so basically what was originally the origin, okay, what was originally the origin is now over here. So this point's going to move to there, and that point's going to move along here. So let me just fix that. Okay, so now basically what's going to happen here is this whole thing is going to shift 2 spaces to the right. Okay, so basically this -1, okay, is going to end up at -1, 2 spaces. So it's going to go, this is going to go from -1 up to where 1 was. Okay, so this is where -1 and this is where 1 is. Okay, so what's going to happen is the whole thing is going to move 2 spaces like this. That's how I wanted to show it. So this whole thing is going to move 2 spaces to the right like this. Okay, so basically what's going to happen is exactly this. All right, 2 spaces to the right, the y values stay the same, the x values remain unchanged. So this is going to be basically the x-axis. This is going to be the 1, -1 to 1 is 1, and then 1, that's going to go to 3. So what we see here is this is exactly the same as the area of f of x between -1 and 1 with respect to x. The area under here is the same as the area under there. They're the same area. Exactly the same area, no difference between them. The shape of this graph hasn't changed. It's just translated. And the shape between -1 and 1 is the same as the shape between 1 and 3 of those, because it shifts 2 spaces to the right. So that area hasn't changed at all. Okay, so we can say that the answer for part 2, okay, is going to be 10.52. So we can say the area, the integral between 3 and 1 of x, fx, when minus 2 is inside the bracket, with respect to x, is going to be 10.52. Okay, the same answer as the original answer. Okay, so there's the answer to part B, part 2 of this question. All right, this is kind of related to translations. Okay, transformations and translations. So I hope you can see what's happened here. The whole thing has shifted across. The area we're looking for is the same area as before. It's just, the whole thing has shifted 2 spaces along. And, the limits have shifted 2 spaces along as well. So therefore the area will be the same. All right, so that concludes this question number 1 from the January 2023 International A-Level Pure Mathematics P2 paper. Other questions from this particular topic or this particular paper can be found in the playlist that will appear over here. Other questions from the topic of the trapezium rule can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and the video up here will explain to you how we can use my channel to find things more efficiently and help you revise for your exams better. Thank you for watching, and see you soon.